Hi, hello guys. Today we're gonna do the continuation of induction motors efficiencies. And last time, as you would like to know, or as you already know, that we did power stages in transformers, and as a matter of agencies, we took only one problem. So let's continue with that problem. We will take few of them in the long run, but for today, let's continue with that induction motors so that we can get more exercise into them. I'm gonna take another problem from Tharaja, and it says a 400 volts, 50 hertz, a 400 volts, 50 hertz, 6 pole star connected 3-phase induction motor consumes, that's the input, because if you got a galvanic stand here and that galvanic stand, okay, let me do it this way. If you've got a galvanic stand and that galvanic stand feed a motor with the connector box, it's something like this. This motor from this galvanic stand consumes 75 kilowatts, meaning this 75 kilowatts is an input to the motor. That's why I'm telling you it's an input. This motor consumes an input of this much. All right, let's continue. It consumes 75. The input is 75 kilowatts, and it's equals to, and it runs at a sleep of 2.5%. And if the stator iron loss is equals to what? Is equals to 2 kilowatts. The windage and friction losses. The windage plus friction losses is equal to 1.2 kilowatts. And the resistance between the two stator terminals, is equal to what? The resistance is equal to 0.32 between the two stator terminals. You divide by 2 so that you can get the resistance of one terminal. Right. Determine the rotor copper losses, the motor power, efficiency of the motor, and the shaft torque developed. Is equal to what? Okay, because of we've got the stator resistance, let's first calculate the stator copper losses already, which is 3 I squared is equals to I squared stator resistance. Or we are also given an input, the input line current of 75 amps. Sorry about that. And then therefore is 3 multiplied by 75 squared multiplied by 0.32 divided by 2 to get the resistance. It's 0.32 divided by 2. It's 0.16. Is equal to 3 multiplied by 75 squared multiplied by 6 is 2700, which is 2.7 kilowatts. This is the losses of the stator copper losses. The stator copper losses. Now, from this, my diagram, this is the output. This is the input, which is given at 75 kilowatts. And then here, we've got the stator. The stator has what? Has the stator copper losses and the iron losses. Already this is calculated as 2.7, and this is given as 2 kilowatts. And then here, of course, we've got the synchronous power. The synchronous power, anything given? No. Then this is the synchronous power. How to find the synchronous power? It's going to be the input power minus the stator losses. And it's equal to what? The synchronous power is equal to the input power minus the stator losses. The stator copper losses and the stator iron loss. You'll get the synchronous power. And it's equal to what? Is 75 minus open brackets 2.7 minus 2 closing brackets is equal to 75 minus 2.7, sorry, 75 minus 2.7 and then minus 2, 70.3. It is 70.3 kilowatts. Here we've got 70.3 kilowatts. Then we come to the rotor. We come to the rotor here. But we still remember, because of the iron losses, because of the iron losses are constant, sometimes they can be ignored. And if they are ignored, then the rotor copper losses is equal to the synchronous power multiplied by slip. And the synchronous power was calculated as 70.3. Then we multiply by, we are given a slip of 2.5%, which is 2.5 divided by 100 is equal to 0.025. And it's equal to what? It's 70.3 multiplied by 0.025 is equal to 1.76 kilowatts. You've got here the rotor copper losses is 1.76 kilowatts. Right. If indeed that the rotor copper losses is 1.76 kilowatts and our synchronous power is calculated as 70.3, then it should stand to reason, of course, here, that the mechanical power is equal to the synchronous power minus the rotor copper power, the rotor copper losses. Indeed, those who were with us from the beginning knew from the we proved these formulas, guys, with our first video. That's why our first video is long, but give yourself time, invest in yourself, go and look at that video, subscribe, so that every time when we get something fascinating or new, you can be notified. And this is equal to what? 70.3 minus 1.76 is equal to what? Is equal to 70.3 minus 1.76, and the answer is 68.54 kilowatts. But we are given what? This is the shaft part, if you remember well. And the shaft part consists of the rotational losses. The rotational losses normally are due to the fan that is installed at the back of the motor and it is mounted on the rotor. And they are consist of the windage plus the frictional losses. And they are given as what? They are given as 1.2. Therefore, it should stand to reason as well that the output here, the output is equal to what? It's 68,54 minus what? Minus 1.2 is equal to what? It will be 68,54 minus 1,2 and is equals to 67,34 kilowatts. Right. This is the output here and is given as 67, is calculated as 67,34 kilowatts. You finish your diagram. You must have 15 marks. After doing this based on the statement, then I will advise you now to visit and answer the questions. The question says, calculate the rotor copper losses. Calculate the rotor copper losses. Gentlemen, you already did that. Here are your rotor copper losses. They have been calculated. And then it says, calculate the motor power. You did that already. That the output minus the rotational losses, it gives you the motor power. The rating or the power which that motor is capable of producing at the output or at the shaft is this. Now, calculate the efficiency of the motor. The efficiency of the motor is equal to what? The output power over the input power multiplied by 100%. This is what? The output is calculated as 67,34 over what? The input was given as 75. And it is 75 kilowatts multiplied by 100. And it's equals to, it will be 67,34 divided by 75 multiplied by 100% to express it as percentage, and it is 89.8%. And then lastly they say calculate the shaft torque developed. The shaft torque, the torque here at the shaft. The torque here at the shaft. Let me erase the upper part, guys, because I don't have space. All right, Van Streyer. While erasing, remember this is given as a 6-pole. This is given as a 6-pole induction motor, and we are given what? We are given the speed. I think we are given the speed. Okay, we are given the slip as 2.5. Okay. Okay, guys, we have to calculate the shaft torque. But before we calculate the shaft torque, you should be able to calculate what? The rotor speed. Why? Because the shaft torque, let's say the output power is equal to the omega multiplied by the shaft torque. But we don't have the rotational speed. We don't even have the synchronous speed either. But we are given two most important points. We are given a 6-pole motor and the slip. Meaning it could mean only one thing. We can calculate the synchronous speed, which is how much? 120 degrees multiplied by frequency divide by the number of poles, and it's equals to 120 multiplied by 50 hertz, and it's equals to what? This is equals to 6,000 over divide by, this is given as 6, it's a 6-pole motor, and it's equals to what? This one will cancel, this one will cancel that, meaning this is 1,000 revs per minute motor. This is the synchronous speed, 1,000. But now, the slip is equal to the synchronous speed minus the rotor speed. Express it as the synchronous speed. So we're gonna do what? We're gonna divide that 2.5 there by 100. Is 2.5 divided by 100. It is 0.025. 0.025 is equals to, this is calculated as 1,000. 1,000 minus NR divided by 1,000. Therefore, the rotor speed is equal to how much? The rotor speed should be, this is very, very important, gents. This is 0.025 multiplied by 1,000 minus 1,000 is minus 975. Therefore, the rotor speed, then we divide by negative in all sides. Then the rotor speed will be 975 revs per minute. Now then that we got the rotor speed, we can come back and calculate the shaft torque, because we have found the unknown. Right. This video is coming to an end, guys. I hope you feel great to treat others. Okay, this output was calculated as how much? It was calculated as 67.34 multiplied by 10 to the power 3 multiplied by 60. Remember, sorry, this was supposed to be divided by 60. Why? To convert that speed to seconds. So it multiply by 60 divide by 2 pi multiply by 975 as calculated is equal to what? The shaft torque. Therefore, this shaft torque is equal to what? It is 67.34 exponent 3 multiply by 60 divide by open brackets 2 second function pi multiply by 975 closing brackets answer, and the answer there is 659.54 revs per minute. And that's your answer. And that's the end of that question, and this is 15 marks. Guys, please don't forget to comment or drop any question you would like us to discuss. Also subscribe and share the information so that we can grow. I will see you in the next video.